Hi guys, welcome back. Today, in today's video, we're going to talk exclusively about two different types of triangles, which we have already talked about previously, but now we're going to go more in depth with it. We're going to discuss the isosceles and the equilateral triangle and some important properties that come about when dealing with both. And we're going to talk about the isosceles triangle to start off with. Remember, for an isosceles triangle, we have two congruent sides. And in this figure right here, the two congruent sides are side AB and side BC. All right. Now we have some vocab. The two congruent sides, those are called legs. So AB and AC, they're congruent. We know they're congruent to one another. These are called the legs. So this is a leg, this is a leg, and the legs of isosceles triangles, they are congruent. The angle where the sides intersect, and the sides they're talking about are the legs, okay? The angle that is created by that intersection is called the vertex angle. And in our example, the vertex angle here is angle 1. All right? So I wrote it in orange over here. I made my little arc over here in orange. Hopefully that'll help. The side opposite the vertex angle is called the base. So let me draw for you how we remember the base. If you know where the vertex angle is, you just have to draw a line opposite of your vertex angle, and that's your base. Now, I know that it's pretty easy to see right here that the base is the bottom of the triangle, but I don't want you to think of the base as the bottom of the triangle because we do know that these triangles can get a little funky and misshapen and in different orientations. So just remember the base is opposite the vertex angle. And the angles along the base are called the base angles. We'll go figure. So those are angles 2 and 3. And notice that I have the two red arcs at angle 2 and angle 3. And the reason why is because of this theorem right here, which is the isosceles triangle theorem. Which basically says, okay, so let me get two color highlighters so I can highlight the hypothesis and conclusion for you. All right. If two sides of a triangle are congruent, then, let me pick a color, then the angles opposite those sides are congruent. And what they're basically saying here is the angles opposite those sides, that's the base angles. Okay? That's the base angles. All right? So we know that since we have in our figure above AB is congruent to BC, we know that angle 2 will be congruent to angle 3. And the way I like to remember this and draw this is, okay, well, you have these two congruent legs right here. So the angles that are opposite of those legs are also congruent to one another. Now, below that, I have the converse. And if you remember, if we have that a theorem is if P then Q, let me write that off to the side. The converse will be if Q then P. So all we need to do is switch the hypothesis and conclusion, which they do, if two angles of a triangle are congruent. Then the sides opposite those angles are congruent. All right? Meaning the legs. The legs have to be congruent. So I can write my example in the converse direction as well. So since I know that angle 2 is congruent to angle 3, we know the sides opposite, which are AB and BC, also are congruent. All right, that's really the big takeaway here today for the isosceles triangle. Let's do some examples, okay? Oh, come on. What's happening? Sorry, my iPad froze up. There we go. All right. So let's take a look here at number 1. Find each missing measure. We want the measure of angle J, and that's right here. And then we want the measure of angle K, which is up here. All right. So remember, angle K, that's the vertex angle because it's the angle that is created by the two congruent sides. And angle J is a base angle. How do I know? Well, I could draw an arrow opposite of the angle, and I see that I'm pointing towards one of the congruent sides. So since I know that in an isosceles triangle, the base angles are congruent, then I know that angle J, the measure of angle J, must also equal 68 degrees. So this is 68 degrees. And to find the measure of angle K, well, remember from the previous video, all the angles inside of a triangle must add up to 180. So the measure of angle K is equal to 180 degrees minus those two 68-degree angles. So this is going to get me 180 minus 136, that is 44 degrees. All right. Pretty simple stuff. As long as you know the properties, you're all good to go. Let's look at number 2. You got to ask yourself, what are you given? Are you given the base angle here or the vertex angle? Well, since we can see that the angle we're given, which is angle D, is created by the legs, which are the congruent sides, then this 106 is the vertex angle. And we know that these two angles down here will be congruent because they're the base angles, right? They're opposite of my congruent sides. Well, here's what I know so far. I know that angle C and angle E, they're going to have the same measure. So what I could do is I could just write 2 times the measure of angle, let's just say C, plus the measure of angle D would equal 180 degrees. I know the measure of angle D is equal to 106. So twice the measure of angle C is equal to 180 minus 106, which is 74 degrees. So the measure of angle C is going to be 74 divided by 2. That's 37 degrees, right? And we already know, because this is an isosceles triangle, that the measure of angle C is equal to the measure of angle E, which is why I could write this statement in the first place. This is the statement I'm referring to, right? So therefore, the measure of angle E is also going to be 37 degrees. Okay. Let's move on to number 5. Number 5, we're given an isosceles triangle. The directions say find the value of each variable. So these two angles right here, they both have expressions in x. Are they the base angles? Well, I'm drawing these lines opposite to the other side. Yes, these must be the base angles because they both point to the legs, which are the congruent sides. So what can I do with these two angles? If I know they're congruent, what I could do is set them equal to each other and solve. So if I subtract 4x on both sides, I get 5x. And if I add 33 to the other side, I'm going to get 40. So x equals 8. All right. Now, did this problem ask me to solve for the angles? No, it didn't. It just said find the value of each variable. So I am done. I don't need to do any more work, which I know we all love. All right. Less work. Number 7. How can I tell this is an isosceles triangle? Do I have two congruent angles inside of this triangle? I absolutely do. So by the converse, so I'm referring back up to here to what we previously learned, by the converse of the isosceles triangle theorem, I can set these two things equal to each other, because if the base angles are congruent, then the legs have to be congruent, and we just go from there. All right, so let's subtract 3x on both sides, so I get 6x. If I add 73 to both sides, I get 96. Divide 6 on both sides, I get that x is equal to 16. And once again, I don't have to plug it back in because that's not what the directions tell me to do. So I am good to go. All right. Here we got some word problems. So like I've said previously, I'm going to continue to say it until you're tired of hearing it. If they don't give you a figure, draw one. Okay? So I'm drawing triangle RST. Does it matter where I draw this? No. Okay, well, I just screwed everything up. We're going to have to deal with that imperfection down there. It doesn't matter what your triangle looks like. You just got to label it and then apply the properties. The property that I'm talking about here is that RT is congruent to ST. So RT and ST, they're going to have their little congruency markings right there. We know the measure of angle R, let me zoom in, is 9x plus 2. And the measure of angle S is going to equal 13x minus 18. And the measure of angle T is going to equal to 17x plus 1, I think it is. Yeah, plus 1. Find x. All right, we need to be really careful. We need to be really careful that we're not setting things equal to each other that we don't know, right? But if you just keep your wits about you, you think about it, you know that this is an isosceles triangle. So what angles are going to be congruent? The angles that are opposite of the congruent sides. So angle R and angle S will be congruent to one another. So I just take those expressions that I was given for those two angles, set them equal to each other, and do some quick math. 13 minus 9, 4x. Add 18 on both sides, I get 20. X has to equal 5. All right. It says find the measure of each angle, so okay, well, let me do that. I know these two are going to be the same, so I just have to pick one angle to plug it back into. So let me do that for angle R, because I think that's the easiest. 9 times whatever x is, which is 5, plus 2. So you have 9 times 5, which is 45. 45 plus 2, that is 47 degrees. So that's 47 degrees. The measure of angle S has to be 47 degrees. So now all that's left is the measure of angle T. Well, T, the measure of angle T, remember, has to be 180 minus those two 47s in there. 2 times 47, 94. 86 degrees. There we go. Pretty simple. How can I know I'm correct? How can I check just real briefly that I'm correct? What do these have to add up to? If I add 47, 47, and 86, I have to get 180, which I do, so I know I'm good to go. Bam. All right. Let's look at 9. Let me switch up my color. I'm getting tired of purple. It's too blue. All right. In triangle DEF, I know that angle D is going to be congruent to angle E. So D and E, they're both going to have that one little mark in there to show they're congruent. We know DE is equal to this expression, x plus 4. EF is equal to 4x minus 8. And DF is equal to 7x, minus 35. Find x in the measure of each side. Well, here's the thing. I know I have two congruent angles, so what are the congruent sides? They're the sides opposite of those angles. So I set these two expressions equal to each other and solve. 35 minus 8, that's going to get me 27. Therefore, x is going to equal 27 divided by 3 is 9. So there I go. What two sides are congruent? DF and EF, right? So DF and EF, these two sides are congruent. So just real quick, let me plug it in. I'll plug it into EF. 4 times 9, and then minus 8. Oh, here's my cat. That jingle bell. 4 times 9, 36, minus 8 is 28. So these are both 28. And then DE, you have to plug back in for DE. There's no rules about the sides. The sides can be however big they want. There is no rule. They're wild and free, okay? So don't try to add them and set it equal to 180. It's not going to work, okay? Don't do that. I know someone's going to do it, but I'm just saying don't do it, okay? You got to plug back in, all right? So there we go. Okay, equilateral triangles, and then we're done. You know equilateral triangles, all the same angles, all the same sides. A triangle is equilateral if and only if it is equiangular. Do you guys remember this? If and only if? What did we call that? If we could write a statement as if and only if, this is called a biconditional statement. Remember? That's why we learned all that crap. All right? If the measure of angle A is equal to the measure of angle B and the measure of angle C, okay, yeah, blah, 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 we got it. Then we know that AB will equal BC will equal AC. And vice versa, because remember, a biconditional, we could write back and forth. If we know the sides are congruent, then we know that the measures of the angles will all be equal to each other. And here's the thing. Equilateral triangles, if all the angles have to be the same, then it's always going to be 60 degrees. Always. Always, always, always. Now, we don't know about the sides. The sides could be 2, it could be 1,000, it could be, I don't know. But if a triangle is equilateral, then all of its angles are 60 degrees. So, for example, find each missing measure. Well, I see that 2 of the angles are 60, so the only other thing that this angle could be is 60. And I know now if I have a 60, 60, 60 triangle, then it's equilateral. So this is 9 feet and this is 9 feet as well. Number 12. I ain't got no knowledge. That was really southern of me. I apologize. But I don't know what the angles are. I do know, though, that these all have one little tick mark right here. So this has to be equilateral. And if I want to know about all these angles, well, if it's equilateral, then all the angles are 60 degrees. Ooh. Real tough stuff happening on this day. All right. And finally, 13. If triangle PQR is an equilateral triangle, solve for x and y. Well, here's what I know. I know that triangle PQR is equilateral. So I could set any of these expressions that I'm highlighting in yellow right now. I could set any of them equal to each other and still get the same answer for y. Okay? So let's just do 14y minus 59 and 9y plus 1. If I subtract 9y from both sides, I'm going to get 5y. And if I add 59, I'm going to get 60. So y has to equal 60 divided by 5. That's 12. And then to solve for x, well, where's x? X is down here. And it says x is the measure, or this expression 7x minus 3 is the measure of this angle r. Well, if this is an equilateral triangle, what does that angle equal? 60 degrees. So 7x minus 3, that's equal to 60. Add the 3 on both sides. Divide by 7. And that's equal to 9. There you go. All right. Hopefully you learned a lot. And hopefully you have a better grasp on how to solve these triangle problems when they give you some unknowns and all that goodness. This is the last video before our first quiz. So as you're watching this video, please, make notes and so that you can ask me in class. And then when you go to study for your quiz, maybe you'll revisit this video or the PDFs on EDSB because they are up there. They're going to stay up there. So thanks for tuning in. Take care.